Hello everybody. Happy first day without me. You're all fine, I promise. Take a deep breath, everything's going to be just fine. Remember, you've already been learning by video for a couple weeks now, so the only difference is that I won't actually be there while you're working on homework to answer questions, but I promise you, you will be absolutely fine. So we're starting a new chapter here. It is all about quadratic functions and relations. And so this first chapter, or this first section that we're going to do today is about graphing. We're going to be graphing these quadratic functions. So we've seen this before, maybe very briefly in Algebra 1, but I'm going to walk you through kind of the intro to quadratic functions as well as the introduction to how to graph them. And we've got a couple different methods we're going to be looking at. So a quadratic function, I'm going to set up what's known as the standard form for a quadratic function. So it looks like this. We start with f of x. Remember, first of all, that f of x is the same as y. We use it interchangeably. We use this because it's a function. Equals ax squared plus bx plus c. All right, so that is our quadratic function in standard form. Let me label a couple of pieces for you. So the ax squared, this piece right here that's attached to the x squared, this is known as the quadratic term. The piece that is attached to an x, that could be a 2x or a negative 3x or something like that, that is the linear term. Notice it looks just like a linear function if we cut this part out, so that's why this is the linear term. And then the plain old number, this is the constant. Okay, so we've got a quadratic term, a linear term, and a constant term that all band together to form the standard form for a quadratic equation. All right, so we've got these two examples of quadratic equations. One thing to point out, g of x, h of x, f of x, it doesn't matter. It's all function notation. So we're going to make a table of values. Now we've got kind of remember our standard run-of-the-mill set of values that we're going to use. We're going to shrink it down just a little bit. So we're going to start with an xy table. So we're going to do g of x. So our function is negative 2x squared plus 8x minus 3. So if you remember, we were doing absolute value functions a couple chapters ago, and we would do from negative 3 to positive 3. We're going to shrink that down a little bit. Now we're going to do from negative 2 to positive 2, and that will be enough values to get us a good picture. So what we're going to do is we're going to take those 5 values and we're going to plug them into this function here. So if we take, and we can do this all right on our calculator. So if you would, open up a new document. Don't save the old one, doesn't matter what it is. And we want to add a calculator page. So here is our function right here. We are just going to take turns plugging these values in everywhere that there's an x. So first I have a negative 2, and then in parentheses I type in the negative 2, and then I square it. That's for the x squared part. And then plus 8, and in parentheses I plug in my negative 2. And then minus 3 at the end. So I plug that whole thing in. It gives me a negative 27. So I fill that into my table. Then I do the same thing for negative 1. I do negative 2, plug in a negative 1 squared, and then plus 8 times negative 1 minus 3. That gives me a negative 13. Plugging in 0 I can do in my head, because if this is a 0 and this is a 0, all I have left is a negative 3. And then I can plug in 1, so negative 2 times 1 squared plus 8 times 1 minus 3. This gives me 3. And then the last one here is a 2. So negative 2 times 2 squared plus 8 times 2 and then minus 3. This gives me 5. Okay, so I am going to plot those values that I've got onto a graph. So they asked us to graph each function. So we're going to set up coordinate points like this. So negative 2, positive 2 on my x-axis. Those are the values that I chose. And then I need to make sure I go as low as negative 27. So let's maybe scale by 5. So negative 5, negative 10, negative 15, negative 20, then we'll have a negative 25. So we need to go just a touch farther there. And then 5, 10. So let's plot these points that we've got. So negative 2, negative 27. So here we go down to a negative 27. And then -1, we plot a point at -13. So here's -5, 10, 15. So somewhere in there. At 0, we have a point of -3. At 1, we have a value of 3. And then at 2, we have a value of 5. So it looked like it was really just starting to slow down here. A quadratic function has a parabola as its graph. So here's what we've got so far. It reaches this peak. Let's plug in one more point just to see what happens. So let's plug in x equals 3 and see what we get. Okay, so if we plug in 3, so -2 and then 3 squared plus 8 times 3 and then -3. So if we hit that, we get 3. So when x equals 3, we get 3. So that would be the last point that we'll plot. So that's this point right here. So now we can start to see the shape that it's going to take. So it comes up like this, goes through all these points, hits its high point, and then it starts to turn around. So we can just kind of symmetrically show what that parabola is going to do. So there's our graph. And again, that's called a parabola. That's the graph of a quadratic function. Okay, so we've got another one right here. We're going to do the same exact thing. Oops, that would be an h of x. So now, just so the same thing doesn't happen here, we're going to try some slightly different values. So let's go with even numbers. So let's do -4, -2, 0, 2, 4, and see if that gives us a little better of a picture of what our graph is going to look like. So we're going to plug these values in again. So 4, and then I plug in my -4 squared, minus 8 times -4, and then plus 1, and I hit enter. So I get 97. All right, that's going to be fun to plot. Maybe we won't. And then 4 times, then I plug in the -2 squared, minus 8 times -2, and then plus 1. That gives me a 33. Then I plug in 0. Again, 0 is easy. I just get 1. Because this term is gone and this term is gone. All I'm left with is the 1. Then I can plug in 2. 4 times 2 squared, minus 8 times 2, and then plus 1. So that gives me a 1 as well. And then when I plug in 4, so 4, and then in parentheses 4 squared, minus 8 times 4, and then plus 1. Okay, so then I get 33. Okay, so again, we're just using this table of values to kind of get sort of a picture, and then we might need to plug something in again, just like we did here. So set up your axes. We have all positive values of the function here, so I don't really need to show any negative values at all. So when I go to plug these in, I've got, I'll make that 2, this is 4, -2, -4, and then when I scale this, I actually want to make sure that I'm going pretty darn high. So let's scale by 25. So 25, 50, 75, 100. So none of this is set in stone. None of this is like, oh, well, we should always scale the y-axis by 25, or we should always scale the x-axis by 2. It's really all according to what you plug in and what values you get out. That will tell you how you should appropriately scale your graph. So let's plot these points. So -4, we go all the way up to 97. So that would be right about there. At -2, we're at 33. So maybe about there. At 0, we're at 1, so that's just barely above the origin there. And then at 2, we're back at 1, so again, just barely above that x-axis. And then at 4, we are up here at 33. So you guys know the way this works. You know the way that these parabolas are supposed to look. It's supposed to be symmetric. So what happens here, it hits this point. We're assuming it's going to keep going down, and then it's got to come back up and hit this point. So we are just going to graph it like that. So we come through here. We're going to assume that it goes just a little bit lower before it turns back around to go through these points. So something like this. And then make sure it's symmetric on both sides. You should be able to fold it in half right down the middle here, and it would look exactly the same. So speaking of that symmetry, we've got a couple of definitions here. So I mentioned that this, you should be able to fold it in half right down that line, and then it should be symmetric. We can do the same thing right here. This is the high point, so we should be able to fold our graph in half right over that line, and it would be symmetric. So that's exactly what this axis of symmetry is. It's a line that if we wanted to, we could fold the parabola in half and it would look exactly the same. So let's write a formal definition here. So the axis of symmetry, this is a line through the graph of a parabola. A line through the graph of a parabola that divides the graph into two halves. Actually, let's say two symmetric halves. So it is a line through the graph of a parabola that divides the graph into two symmetric halves. Just like I said, that means you should be able to fold it right on top of itself, and it would end up laying right, like one side right on top of the other, like this one. Okay, so I'll give you a second to make sure we have that written down. Okay, so the next definition that we have here is something called the vertex. Now, both of these parabolas have a vertex as well. It's the highest point on the graph if it's flipped upside down, or it's the lowest point on the graph if it's right side up. So that's the vertex, and notice it falls right on this line, because that's kind of the dividing point. It's like it goes up until it hits its high point, and then it goes down after that, or it goes down until it hits its low point, and then it goes up after that. So the vertex is right on that line of symmetry that we just drew in. So again, let's get a real definition here. The vertex is the points, let's see, where the graph intersects the axis of symmetry. So it's the point where the graph intersects the axis of symmetry. So then one thing that I should point out, and this is really the most important part of the vertex, is that it's either the highest point or the lowest point. So depending on the shape, whether it's right side up or upside down, the vertex is either the highest point or it's the lowest point. Okay, so that part is very important. Okay, so the graph of a quadratic function, we're going to kind of put some pieces together here to find we need an x-intercept, we need a y-intercept, we need the axis of symmetry, and then we need the x-coordinate. All right, so let's get a whole bunch of features here. So we want, like I said, y-intercept, axis of symmetry, and then the x-coordinate of the vertex. Okay, so 3 different pieces, and these, we already saw graphing using a table. Now we're going to see graphing using these 3 features, the y-intercepts, the axis of symmetry, and then the x-coordinate of the vertex. All right, so first one, the y-intercept. If we plug in, like let's write standard form, y equals, if we do A, we plug in a 0 for x, plug in a 0 for x, and then plus c. Because remember, your y-intercept happens when you plug in a 0 for x. So if I plug in 0 for x, this x value is 0, this x value is 0. These terms are essentially gone. All I'm left with is the c. So the y-intercept is always c. It's just that number that's hanging out on the end. So see here, I had just a 1 hanging out on the end. That was my y-intercept. Here I had just a -3 hanging out on the end. That was my y-intercept. So that's a pattern that's going to happen every single time. The axis of symmetry, there's a formula for the axis of symmetry. This is very important. This is something to memorize. It is x equals -b over 2a. So x equals -b over 2a. And we will talk about that in just a moment. And then the x-coordinate of the vertex is that same x value, -b over 2a. So when we're talking about b an A, in case you're wondering what on earth those things are, go back to the standard form that we have right here. A is the number in front of the x squared, B is the number in front of the x. So that's what I'm talking about when I talk about A and B. So these are our formulas that you need to have memorized, so make sure you've got those written down. So based on the vertex, based on the axis of symmetry, based on the y-intercept, we're going to use those three things to plot a few points and then graph a parabola. So let's go ahead and flip the page. I've got a three-step process that I want you to write down for exactly how we would do that. Okay, so three-step process. First step, find the axis of symmetry and the vertex. Oops, sorry. Find the axis of symmetry and the vertex. So find the axis of symmetry and the vertex. That is the very first thing you're going to do when we're plotting by this method. Like I said, we already plotted using tables. Now we've got a second method that we can use. So find the axis of symmetry and the vertex. That's the first step. Then find the y-intercepts. And its reflection. Okay, so the y-intercept and its reflection. So that part is important. I'll hit on exactly what this means in just a moment when we're looking through our example. And then third, connect the points with a smooth curve. That's our parabola. Okay, so there are your three steps. So again, I'll pause for just a moment to make sure that we've got that all written down. Okay, so our next example here that we're going to look at, this is a new equation. This is a new parabola that we're going to graph. We want to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So I know this is kind of broken down bit by bit. I want to kind of follow the examples that we've got right here. So find the axis of symmetry. So we've got a formula for that. So the axis of symmetry, the AOS, we've got a formula. It is x equals negative b over 2a. So again, let me quickly write down standard form. It is ax squared plus bx plus c. So again, when I talk about b, I'm talking about the number that's attached in front of the x. So here I want negative b. Well, if we look right here, let's label these numbers. So this right here is a. So that's negative 5. That's the number attached to the x squared. Negative 10 is b. That's the number attached to the x. And then 6 is c. So just so we know exactly what those numbers are when we talk about a and b and c. So here negative b would be a negative 10. Of course, a negative 10 comes out to be a positive 10 over, and then 2 times a would be 2 times negative 5. So I get 10 over negative 10, which is, negative 1. So x equals negative 1, that is my axis of symmetry. So I also have the x-coordinate of the vertex. So that's the very same thing. The axis of symmetry is the very same thing as the x-coordinate of the vertex. So in just a moment, I'll find the whole vertex in step B. And then I find the y-intercept. So the y-intercept, remember what I do for y-intercepts, no matter what the equation is I plug in a 0 for x. So y equals negative 5 times 0 squared minus 10 times 0, and then plus 6. So the terms with 0 are nothing. All I get is 6. So 0, 6. That is our y-intercept. Okay, so now table of values, we want to make sure that we're including the vertex. So this is step 2 up here. Actually, we're still on step 1 because we haven't found the vertex. What we do with the table of values is we select some x values, we get some y values. So including the vertex, we know that the x-coordinate of the vertex is negative 1. This part is very important. We know the x-coordinate of the vertex is negative 1, so we have to make sure that we are plugging that in. Okay, and then I have another point that I'm going to plot, but I'm going to wait just a moment for that. So in terms of y, what I'm going to do is I'm going to plug in the -1. So I have -5 times -1 squared, and then minus 10 times -1, and then plus 6. So I am plugging the -1 into my original equation here. So let's just type that strand into our calculator. So -5 times -1 squared, minus 10 times -1, and then plus 6. Okay, so when I hit enter, what I get is 11. So I get 11. So that is my vertex, -1, comma 11. Okay, so I know that that is one of my points. This is the vertex. Okay, and then like I said, once I set up the graph, which I'm doing right now, I'm going to show you one other point that we want to plug in. So back here, find the axis of symmetry in the vertex. Got it. So let's plot those things. Okay, so our vertex, our axis of symmetry, the vertex lies on that line. So -1 is our axis of symmetry. It's a vertical line that folds our equation in half. So you should always plot the axis of symmetry using a dotted line. So we're going to start there. So x equals -1 is my axis of symmetry. Remember, x equals lines are always vertical, so I start by plotting that with a vertical line. Next, I am going to plot the actual value of the vertex. So I'm going to skip down by 2. So -2, -4, 6, 8, 10. So down just a little farther than that is the -11. All right, so that's where I'm at so far. Next, I'm going to plot the rest of my points. All right, oh, I'm sorry, that's not -11, should be +11. Let's go the other way. 2, 4, 6, 8, 10, so just a smidge higher than that. There we go, that looks better. So -1, +11, sorry about that, just ignore that x in there. So the next thing we're going to do, part 2, find the y-intercept. So we've got the y-intercept, it is 0, 6, so let's plot that point. So 2, 4, 6, there's my y-intercept. And then finally, the last part is the reflection of that point. So I'm going to plot the reflection of that point. So here, if I were to do a mirror image, I am 1 unit away from my axis of symmetry. So I go 1 unit in the other direction and I plot this mirror image point. So these two, if I am looking at these 2 points, they would be mirror images of each other around that line. Okay, so they are the exact same distance from the line. They have the same y value because they're mirror images of each other. And so I know that if I plug in this x value is -2, I know that if I plug in -2, I'm also going to get a 6. Let me just confirm that, kind of prove that this mirror image thing works. So -5, if I plug in a -2 and then square it, minus 10 times -2 and then plus 6, I get 6. So that is my other y value that I'm going to plot. So that was step 2. And then step 3, connect the points with a smooth curve. So parabolas are smooth. They're rounded. They're not pointy like the absolute value curves are. So our graph will look something like this. All right, so work hard on your homework. You guys should be in your new groups. And then what you don't finish in class is for homework. And I will make sure I go over a problem or two in the next video. All right, good luck.